Hello, today we are going to demonstrate our autonomous invoice processor and vendor assistant built for the Agents for Business track. Traditional automation fails when processing corporate invoices because documents vary wildly, vendor profiles change, and billing data is entirely unstructured. We need systems that don't just extract data, but reason through historical context to detect financial fraud. That is why we built an agentic solution using the Google Agent Development Kit, ADK 2.0. Our system operates as an intelligent multi-agent graph that chains document extraction, live database auditing via the custom model context protocol, and real-time anomaly detection into a single cohesive workflow. This keeps human managers in the loop exactly when critical escalations occur. We leveraged the natural language scaffolding engine inside Google Anti-Gravity 2.0. By passing our core engineering goals directly into the app prompt panel, Anti-Gravity initialized our workspace, mapped our local dependencies to our single root virtual environment, and generated this complete, production-ready implementation plan. As you can see in this walkthrough artifact view, the platform automatically laid out our two-node graph workflow, establishing Node A as our extractor agent and Node B as our auditor agent, while ensuring our custom local Python MCP server was securely attached to the tool registry. Our architecture handles production data across three distinct layers. First, our agent orchestration layer manages state transitions between our nodes using the Gemini API. Second, our tools layer runs on a custom, lightweight Python model context protocol, MCP server. Instead of exposing raw data to prompt injections, this server wraps our local database and securely exposes three targeted tools: Get Vendor Metrics, Get Historical Unit Price, and Get Approval Threshold. Finally, our data layer relies on a local SQLite database seeded with unique vendors and over 40 distinct pricing histories, allowing the system to instantly audit transactional baselines. Next, let's validate our implementation using our custom agent CLI skill. Our agent CLI delivers a rapid, developer-centric feedback loops. When I invoke our main entry script with a target file path, it spins up our multi-agent workflow, coordinates background execution states, and streams real-time, color-coded telemetry logs directly to the screen. First, let's run a standard invoice. Notice the logging feedback stream. The extractor agent node passes the PDF layout. The auditor agent invokes our background MCP server tool, confirms the unit cost perfectly, matches our historical SQLite database records, and returns a clean, green approved status. Now, let's process an anomaly PDF. The auditor agent instantly flags a massive 10 times price spike violation against the historical baseline. It outputs a critical red terminal warning and immediately sets the system state to needs human override. Simultaneously, it drops a structured critical risk escalation.md markdown file right into our workspace, instantly alerting human managers within our environment. Beyond our terminal, the Google Anti-Gravity walkthrough view allows us to verify these exact same test cases visually. This confirms our multi-agent compliance rules are executing flawlessly across both our developer CLI and our central project dashboard. To conclude, let's look at the codebase structure. We have separated our system into two core files. On the left is our main execution script, which establishes our command line skill and securely routes our terminal arguments. On the right is our agent workflow file, which utilizes the Google Agent Development Kit framework to map our multi-agent state graph and register our custom MCP server tools. This implementation proves how autonomous agents can securely bridge old databases with modern reasoning models to protect business compliance. Thank you.